Today we sorry, go ahead.
Oh no, go ahead.
Um okay. So today we're talking briefly about what we're gonna do in Bangkok. And no Yeah. So we're gonna talk briefly about how you can find us there. And then we're gonna jump into the protocol updates and top chain updates. So you can follow up what we have been doing for the past 2 weeks, and you can ask questions at the end. But you should take notes of your questions. You can drop them in the chat during the call, and we'll answer everything at the end of the call. So all questions are valid. Yes. We can start with the answer. I think you all know that, but we are on Telegram. This is our main communication channel. So I'm gonna drop the link in the chat, and you can just join because that's how you can actually find us on a daily basis in when we are in Bangkok. We're not announcing any event yet, but we're gonna be present at many events, and you can find the whole team there. And wherever Okies will all be, because he's the guy, right? And we can all find each other there. So we're exploring communities and like events related to topology and all. So join Telegram, and yes, that's it. Just in case you are not there yet, I think JK, maybe you are not there because I don't remember seeing you magnified. I don't remember seeing you there either, but otherwise, I think everybody's there. So it's good. And you can share with your friends, of course. But yeah, and that's it on how you can find us. Very short.
Okay, here comes the updates on the development of the topology protocol. So we are working on multiple things. What's done since the last community call is the RPC feature. So we're allowing topology nodes to be able to respond to RPC requests. The reason behind such feature is more on the next slide, but this is an important feature to have for the topology node. On the working on, so what we're currently working on in terms of the core features of the topology protocol includes finality research. So we have a couple approaches that we have some confidence in, and we are currently fleshing out the details and having more internal discussions on how that can be implemented and what are their assumptions, what are their limitations, and what scenarios can it support, what scenarios would it break, and so on before we proceed to implementation. The second item is DHT for topic discovery, or in plain English, it is a big table that is stored in a very distributed manner, and the table contains who are in which CROs. That's what this means. But I think one little detail that is important is that this list is not meant to be global golden information in the sense that you don't go to this list to see everyone that is in the CRO at a given moment. It doesn't give you that information. What it gives you is a few contact points for each CRO. So when you want to join a CRO, you have a few guys in those CROs that you can connect with and ask for synchronization. So you get to know about the latest states of the CRO. And the full name of this entire setup is called the topic discovery. Okay, the third item is infra. There are lots of infrastructure side work that we are building. On the topology protocol side, one such infrastructure is to scale the number of bootstrapping topology nodes that we're running and to have a way of deploying such nodes in a more configurable and automatic manner. And what are bootstrap nodes? Bootstrap nodes are when you start a topology node in your browser, for example, and you come online, the first thing you do is you dial um, bootstrap nodes and ask about some other nodes in a network that you can connect to. So it is basically a touching point for new nodes coming in the network to find someone in the network to connect to. Hence, it's called bootstrapping. And we're currently running such infrastructure ourselves, and we're looking to scale such infrastructure. The last item is documentations. We're working on making great documentations. The stuff we're building here is quite novel to um, a lot of developers that we're talking to, and so documentations need to be great, easy to understand, and relatable. So we're working on that. Moving on to the blockchain side, what's done since the last community call, um, primarily making unit tests. So we have built a series of unit tests against core features and functionalities of the blockchain that we're currently implementing. And the I on the for the things that we're currently working on, first we have um, this implementation of provider submitting their progress, and we understand that there's no complete public documentations on what exactly this means. So if you are first coming to this is your first community call, then this may be a bit confusing. No, actually, totally confusing to you. Um, but I'll go through the list and ask us any question. I can also give everyone a TLDR of what things mean here. But first item is about providers in our blockchain submitting progress, which means that they are reporting the job that they're doing. Um, Again, our blockchain is for providing subscription service for CROs. So these providers are the subscription service providers or nodes in the blockchain that are doing the work and attempting to profit from the fulfillment of the work. And the way they participate in the work is they um, perform subscription and they report their progress on the CRO. So what information they have on the CRO. So they need to submit their progress. Which brings us to the second item, which is fraud-proof challenge. Our current idea is that we have a challenge system for anyone to challenge any progress submitted by any provider. And if such a challenge happens, then they engage in a process of figuring out if the provider was lying about the progress or if the challenger is correct. Sorry, if the challenger is being mischievous and it was actually an invalid challenge. And reward and punishments will occur accordingly from the outcome of the challenge. And on a high level, why we're doing this, because we have providers in a decentralized network, which is the blockchain here, that are providing services. But we also need a way to check that they're not lying and to have this whole incentive systems and validation systems set up around. So this challenge system is our current idea and what we're currently implementing. The third item is infrastructure. So we're also working on infrastructure on the blockchain side. Specifically, we are um, we are beginning to run validators ourselves and to build the deployment flow of running validators. And there are many infrastructure side items that we will be working on for the blockchain to be useful and to be visible, observable, and so on. And these are all the updates. So again, we have Topology group chat as our primary mingling ground for our community. And for those of you who are interested in our code base, they're all open sourced on the Topology Foundation GitHub. And finally, we have a long list of issues, many of which are welcoming contributions, and you can find them on OniDust. We are on OniDust. That's it for the call this week. And this is the, now we go into the AMA session.
People are typing. Let's see if those are answers. I'm going to drop the link here. That's all right. Oh, save questions. Yeah. Yeah, some people joined. Now we have Leo Young joining, and we have, I cannot pronounce, I'm sorry, many stars and spaceship, maybe. Okay, so QEB asked, around the infra part, apart from Ansible, what other tool will be implemented? Terraform or something else? Oh, Oak can answer, so he's answering on the chat. He said no Terraform. If you want to compliment, it's okay, good.
Yeah, Oak knows this part way better than I do. And I think it's being answered in async now.
Yeah. We have a question from JK. If we want to get Pixel Law on CRO, where should we start, knowing that documentation is in development?
Yes. So go to, let me share my screen is being shared. So go to this repo, ps-topology under our GitHub organization. This is our TypeScript implementation of the topology protocol. If you go to the examples folder, there are currently 3 examples, all end-to-end web applications built on top of the protocol. And I think Pixelall is a pixelized space where people can build applications on top, right, in a shared pixelized space. So in that case, the best place to start probably is this example, the Canvas example. And I'll point you to which particular file you should look into. Is under objects, you go to canvas.ts. This is the code of a CRO that implements a 2D canvas. And I think in this, as you can see, have width and height. Let me make the screen larger. You have width and height, which is the dimension of the canvas. You have canvas, which is 2D array of pixel values. So we have a RGB. We have just pixels in each location up on the 2D. I think for pixel law, if I remember correctly, you can actually attach programs and logic to each pixel. So it is much more complex than this example. But I hope this example gives you some idea of the structure of a CRO. And this should be familiar, right? Constructor basically is what happens when a CRO spawns into the network. So you initialize stuff here, and then here are the functions that your CRO accepts. So let me go to one particular function for you. Okay, which is this one. No, actually, we talk about, yeah, I think this one is good. So we talk about paint, right? So painting on a canvas, right, is pretty straightforward. You specify which location you want to paint at, two numbers, X and Y, and you specify the color you want to paint that pixel into. That's it. So that is your paint function. And you want to be very careful about two particular functions. One is resolve conflicts, this one, and the other function is merge callback. These two things, if you haven't read the white paper or understand how our CRO works, it can be quite strange and unfamiliar. But I assume you come from a smart contract world, and smart contracts typically don't have this. There's no such thing called conflicts in the smart contract land, and there's no merging in the smart contract land either. So it doesn't make sense to have a callback for merge from the smart contract land. So I encourage you to go to the white paper. And also, there are two blogs that we have already published on this website, blog.topology.gg. And I hope that these two blogs give you a good foundation to understand what topology protocol is and what CROs are. I think these are good starting points before you touch the white paper even. So once you have good ideas of what merge means and what conflicts means, you can come back and check these. I can explain a little bit what merge callback is, but warning, is way better if you develop the understanding from the bottom up about hash grabs, about how CRO works and how they maintain consistency, all that. But I can tell you what happens here. What happens here is this thing. Let's start with merge. So every CRO keeps its operation history, but it's underneath, it's behind the scene. You don't manipulate it directly. So whatever you do to your CRO locally, it is recorded in the underlying operation history, which looks like a DAG, a DAG. Or we call it hash graph, but you can understand it simply as an operation history, that everything that has ever happened to your CRO. Okay, so if you have a CRO and you locally do things to it, it is recorded in the underlying history, the hash graph. And if you hear about any other operations done by anyone else from the network, I mean, done to the same CRO, they are also recorded in your hash graph. So your hash graph is the source of truth, everything that has ever happened to the CRO that you know of locally. And so merge callback basically means that when your graph receives new information and gets updated in a simplistic sense, it's merge happens because it's merging new information into itself. So it's a merge operation. When that happens, the magic behind the scene will trigger this function. Hence, it's called merge callback. And whatever you implement here in your function is going to happen. Right. So this basically means on a high level, whenever your underlying operation history changes, what you want to do with the history, you write in this function. And obviously, what you write in this function will be parsing the graph, basically taking the operation history and compute your CRO state from the history. That's what you do in this function. Is that clear or anything unclear? Tell us in the chat and Patty will relate to me.
Mhm.
Okay, yeah, but just as a just as a reminder, go to TS Topology. That this is the official and currently the only implementation of topology protocol that we know of. Maybe there are secret implementations of the protocol somewhere. And go to examples folders, there is a basic 2D pixelized canvas example. There is a super basic chat room example. And there is a grid example, which is a super simple multiplayer 2D space where everyone looks like circles and they're moving on the grid. Okay, these examples should be useful. Okay.
So JK said that sounds pretty clear to him, and his last mental model were the different snapshots. So merging different snapshots into a source of truth. Yes. I don't know if I read it correctly, but
Snapshot, yeah, yeah. I think we're using snapshot in a different context, but yes, everyone has their own view of what the CRO currently is, um, the operation history, and these histories are being transmitted and propagated to everyone else on a constant basis, and they're always merging with other histories. And the key property of hash graph is that two valid graphs, they're always mergeable. So if you do something to the CRO, I do something to the CRO, and if we're honest guys, we're doing things that are legitimate, then our histories are always mergeable. And if I merge your history and you merge my history, then our history will be identical. That's called consistency. And because your CRO state and what you renders on the screen all comes from the history, right? So if we have the same history, then we'll be looking at the exact same thing on our screens.
So asked when pixel law and CROs. Pixel.
I think Pixel Law, if I remember, maybe I'm confusing this with another project, but I think there is a $1 million homepage project on StarkNet recently. Is Pixel Law involved in the project?
He said yes, but it's different.
Mm.
Pixel law will be on StarkNet mainnet. Things.
Mm. Yeah, I highly encourage you to try out the Canvas example. Run it locally. Feel how maybe run multiple clients of it, or um, ask your friends and teammates to run the clients with you, so you actually get to collaborate. I mean, paint on the same canvas together in real time, and you get to feel how real time and responsive it is. Any other questions from the chat?
Oak ask it when are you going to deploy those examples under canvas.topology.gg?
Yeah, we can do that.
Sure.
We can do that. We can deploy all three of them. Sure.
So maybe we have a question coming. Yes.
Yeah.
So Leo Young asked, will the topology CRO be built in Cairo or on top of StarkNet? Since we are talking about StarkNet, I think the question.
Well, I think it can be built in such ways, and it can integrate with StarkNet, and there's nothing stopping anyone to do that, actually. I think currently our team is all hands focusing on core features on the topology protocol side and also on the blockchain side. So it's currently not our priorities to integrate with any particular existing blockchains, but there's nothing stopping anyone to do that. And that is actually a core idea that we had very early on, is that topology protocol is supposed to be playing nice with any blockchain. It's not trying to scale Ethereum. It's not trying to scale Bitcoin. Um, it can scale. It's if Topology protocol actually turns out to be as scalable and as magical that we think it is, then it benefits everyone. It benefits every blockchain that integrates with it, including Starknet in this case.
Maybe. Yeah. So, okay, sorry. Oak, what did you understand with the question? Okay.
Hello.
Hey, Oak.
It's way easier for me to try to go over the question
Yeah,
here to say
sure.
what I understood from the question. So the question is, will the topology CRO be built in Cairo or on top of Starknet? And the thing is, you were answering like the question was, are we going to integrate CROs with Cairo and Starknet? And so I think your answer was perfectly fitted for that question. For the question of the CRO being built on top of Cairo or Starknet, the answer is a bit different. It's more nuanced in the sense that CRO have lots of properties like the pub subgroups and all of that that blockchains can't work on that level of peer-to-peer networks nor anything. So the thing is, a CRO being built on top of a blockchain is actually not something that the topology protocol allows at all. Right? Yes? No? Maybe? Yeah, I got cut off.
I can still hear you, but I think he got cut off.
GG got cut off. Okay. So I'm answering for GG then.
Yeah.
So the answer here for the what GG is still sharing the screen. But it
Yes.
seems that the video and the audio got cut. The thing here is CROs are a construct that we are creating using the CRET's technology, and the part of that also the peer-to-peer pub subgroups and all that for us to propagate all the operations that we are making within the CROs. And the thing is, if you are building that on top of a blockchain, you can't inherit those pub sub groups that CROs are benefiting from. So the thing is, actually, you can't build on top of a blockchain itself. But a part of that, this is just, I think, answering your question super straightforward. But Gigi was talking about another thing that is all the things that we are building are actually supposed to integrate with blockchain stuff and blockchain smart contracts and blockchain Cairo contracts and all that, and having CRO integrations that replicate the state of what is the CRO look like within the topology network. Gigi, do you come back to us?
Can you hear me now?
Yes, yes, yes. I think you
Okay.
cut off for a second. Did you hear what I was saying?
Yeah, I heard everything.
Yep.
Yep.
What do
Yeah.
you think?
Well, built on top of Starknet. I mean, in the regular sense, if we build on Starknet, it basically means probably one of the two things. We either make a smart contract on Starknet or we make a layer 3 on Starknet, but we're not doing either smart
But
contracts or layer
even
3 on
that case,
Starknet.
even that you don't have the CRO as we had it defined built on top of the blockchain itself, because then it can't propagate the operations in the pub subgroups and all that, which is
It's
inherently
not it's not doable with blockchain nodes. You have to do with topology nodes.
yeah, exactly.
Yeah,
The thing
yeah.
is,
So
of course, then you can
topology
have
node.
the CRO integrations with you can have a one-to-one replica of CRO with the smart contract CRO. Yes. The thing is that CRO still needs to live within the a topology node. And the thing is, the cost of maintaining that replica might be high.
Well, it's interesting though, to cover the Cairo question. Will the topology CRO be built in Cairo? Well, it can be, and there's a lot of implications, right? If you create a CRO in the Cairo language, it also means you need to be able to run the CRO in Cairo, and which means that wherever you run needs to be able to run Cairo, execute Cairo in the Cairo VM, and we actually did similar things before, which is Shoshin. So
Yes.
for
I think that actually
yeah,
that's a different thing, but yeah, I totally forgot about that one, and that one is right. You can build it on Cairo, not deploy it on chain.
for sure. Yeah, so for Shoshin, we have a web application and we have a WASM environment, which is able to emulate the Cairo VM. And inside the Cairo VM, we can run Cairo smart contracts. And guess what? Guess what we ran in the Cairo VM? We ran the Shoshin Cairo contract. So that was how we were able to run Shoshin Cairo logic locally in a browser. Is through that, and we just replace Shoshin with CRO. Yes, you can do it.
It's the same logic that we've been always talking about. That currently, yeah, for the logic we are using it, compiling it to WASM now that, but it's supposed to be VM abstracted. So actually, you can run any VM there. It doesn't mean that it's going to be deployed. If you use Cairo VM, it's going to be deployed on a chain like Starknet or L3 or whatever. But you can use Cairo VM as the programming language and the VM that's running the bytecode. Totally possible. Yes. So I don't know the name. So the star person asked, is there a limit to how many peers can be in the same object? That's still something that we are figuring it out. So okay, that's something that we are still figuring out. Um, the thing is, you can have many people running on the same object. The thing is, you might have some lag if you have people from super far away places, and that might lag also the message delivery within different geolocated peers. Cool. Can we say that Topology is a decentralized open protocol for metaverse? Chain agnostic. GG. This one is for you. I
I
want you
mean,
to answer this one.
it checks a lot of boxes that that I think they're quite accurate.
Yeah, me too. I'm going to drop off here. I just wanted to clarify the other question, so you can just. I stole the stage for like 5 minutes. Sorry, guys.
Yeah, that was great. That was highlight. We have the we have the um, chef behind uh, a lot of code that's being written for the TS topology, the current implementation of the topology protocol. So, any questions about details of the implementation, how it's supposed to work, how it's currently working? Go to the chef. I think chain agnostic in the sense that what we're creating here, the topology protocol, is complementing what blockchains are good at. And it's good at something that blockchain is not very good at. And so together they're stronger. But topology protocol is not favoring any particular blockchain. It's a standalone open protocol. You're right, and it runs on the decentralized internet. JK is asking what requires a chain to integrate with CROs. Well, so there are many possible ways to integrate, right? But I think on the super high level, integration between a blockchain and a CRO goes in two directions, and each direction has two possibilities. Actually, four possibilities. So the first direction is from a chain to a CRO. That's your first direction, and you can either go with readability or writability. So that means that can a CRO read from a blockchain? Can a CRO write to a blockchain? And vice versa, right? Can a blockchain read from a CRO and can a blockchain write to a CRO? There are many possible paths and there are many possible kinds of integration you can do with different kinds of behavior. The blockchain that we are currently making counts as a kind of integration, but it's a quite unusual kind of integration. It's a very intimate kind of integration, and because our blockchain is not a general purpose blockchain like Ethereum um, or Solana or any of the blockchains that you can write any smart contracts on, our blockchain is just providing a particular service to make the um, a subscription service for CROs to be more useful in that regard. It's not required, but with our blockchain, it helps CROs. So if you go to our blockchain repo, you can check how we're doing it, and you can understand a bit how such integration is being done. But that integration is not replicable to any other blockchain. So take any blockchain like Starknet, or let's take Starknet for example, right? So one important integration that we imagine is for information on a CRO to go onto Starknet. So imagine you have a smart contract on Starknet. Something happens in this CRO, and your smart contract wants to learn about the information there and do some other things, such as transacting with other smart contracts. So you need information coming from CRO to your smart contract. Well, we're currently working on a core feature that is directly helping with this kind of integration, which is finality. And what finality means is that CRO here is able to send information that is finalized to any blockchain, or in this case, a smart contract on Starknet. And it's obviously the question is why? Why does the information has to be finalized before sending on chain? Well, we all know that blockchain is a place that is quite unforgiving in the sense that if you do things on a blockchain, typically it's not reversible. If you send money to someone else, it's what's sent is sent. Unless you ask that person to send it back, then you can't really revert that operation. So things done on a blockchain should be done in a very careful way. So then when CROs communicates with a blockchain, sends information to a blockchain, you likely want to make sure that that information is finalized. It's something that is quite agreed upon by the actors or the participants of the CRO before you can consider it in your smart contracts on your blockchain. And we're currently working on this core feature, which we think will unblock such an integration. Okay, I see the follow-up question. JK said, thanks. Sorry to possibly take him. No, it's totally fine. Ask us anything. You mentioned that hash graphs only merge if they are both valid. How do you prove completeness? Completeness. Can you oh I see. I think the question is updated. How do you prove validity? Okay, so the question is if I receive, so let's say if let's say Patty and I were both in the same CRO, and I have a hash graph, Patty has her hash graph locally, and Patty sent me her hash graph. Now, if I just merge them naively, then I may be screwed in the sense that maybe they're bad stuffs. I don't know. It depends on the mood of Patty on the day off. Maybe. So I may not want to always trust Patty in this situation. So what do? I examine the hash graph that Patty sent me, and you check multiple things. You can do checks that, okay, for the information that Patty is sending me, can I um, graft it on into my graph? Grafting in a sense that if Patty is telling me something that she did to the CRO, do I understand all the dependencies of what she did? And if I don't understand some of the dependency that she did, and if those dependencies are nowhere to be found, then I'm going to say I do not recognize what Patty did there because I can't really connect it in a transparent way into my local history. So I don't understand it, and therefore I'm going to reject that. So this is the checking that's happening behind the scene. Yes, that will be great. And if you like reading papers, the reference section is quite long. So yeah, there's a couple dozen more papers for you to read. Um, the if you want to understand hash graphs specifically, there are go to the hash graph section in the paper and ask us any question on Telegram. Also, I think the section actually quotes a couple key papers that we are um, taking our primary inspiration of the hash graph design from. And so if you go to those papers, you can understand hash graphs perhaps better because our paper was not written in a way that is super educative, but the papers that we're quoting from, or referencing, those papers explain the details very well. And there's always the code base you can check. So if you go to TS Topology, you can check how the hash graph operations are implemented. You can understand its behavior there. But just notice that the white paper um, describes in quite a high level of how the protocol should work. So it is not a specification. So you may find small discrepancies here and there, or you may find the TS topology is implementing some details that is not mentioned anywhere in the protocol, and that is totally fine. Eventually, the goal will be we write a specification from all the learnings and lessons and details that we know are working from our implementation. We distill all of that into a specification, and the goal of such specification is anyone can implement the topology protocol in alternative ways, in different programming languages for different environments. So long as your implementation follows the specification, your implementation can work nice with any other implementations that also follow the specification. So, for example, if you create a Go implementation of the protocol, following the spec, then your Go implementation can work with our TypeScript implementation, and so on. Any more questions? We're approaching the 15-minute mark.
Mhm. Yes. I will call for questions.
But these are great questions. I think it really goes into important pieces of the protocol, how it can work and should work.
All right. I think that's it.
Nice. So we
Thank
can
you,
wrap
everyone.
the call. Yeah, thank you everyone for joining.
Yeah, thank you, Beauty, the for the call and for all the explanations, and thank you for Oak for coming by, being the highlight, and see you in Bangkok, everyone. Well, we have another community call before that, still, but we're planning to go. We meet soon.
Thank you for coming to the call. Cheers and take care. We'll see you in the next community call and or Bangkok. Bye bye.
Bye, guys.